Hello, my dear students. I am Mukesh Tilwani, Assistant Professor in M.L.V. Textile and Engineering College, Bhilwara. Welcome to the third lecture of electric arc welding. In previous lectures, we had discussed about the principle of arc welding, and in previous lectures we also discussed about the coating in the electrodes, and now in this lecture I am going to discuss about the binders used in electrode and welding currents and the arc length. What should be the arc length for proper welding, and effect of arc blow. First of all, binders. AC arc welding used potassium silicate binders. DC arc welding used the sodium silicate binders. And potassium has a lower ionization potential as compared to the sodium. So ionization potential we get in AC welding, arc welding mode as compared to DC arc welding. And arc must reignite itself after every crossing of the zero current instant. Reignition requires the voltage higher than the normal arc voltage. Now the welding flux, available in three forms: granular, electrode wire coating, and electrode coat. We had discussed in previous lecture about the welding flux. This is a position of the arc, the welding, travel welding, the position of the electrode for the horizontal welding. This is a horizontal welding, and this is a position of the electrode, 20-degree direction of the travel. This is the direction of the travel. About 20 degrees from the direction of the travel should be the electrode position for the horizontal welding. And for the vertical welding, this is the vertical welding. In this, the electrode direction should be 90 degrees from the horizontal. Welding currents. The magnitude of welding current depends upon the thickness of the welded material, type of joint, welding speed, position of the weld, and the thickness and type of coating thickness and type of coating on the electrode, and its working length, which is arc length. It is depend on these parameters. But in the practical point of view, the welding current should is depend upon the diameter of the electrode, which is I is equal to K into D, where K is a constant, which is 45 to 60 for ordinary steels, and it is 18 to 22 for graphite. And it is 5 to 8 for carbon electrodes. These all three are for electrode materials. 45 to 60 for steel, and 18 to 22 for graphite electrodes, and 5 to 8 for the carbon electrodes. Now the welding voltage. Arc voltage depend only upon the arc length. This is the linear relation of the voltage versus arc length. Here small l is arc length, where small l is the arc length in mm, and K1 K2 are the constant. The values of K1 and K2 are from the 10 to 12 and 2 to 3. This is the linear relation of the voltage versus arc length. And for the minimum arc voltage, this is a relation for minimum arc voltage. Now the arc length. As already defined, it is the distance between the end of the electrode and the surface of the molten metal on the work. For getting good welds, short arc length is necessary because it permits the heat to be concentrated on the joint, and more suitable due to the reduced arc blow effect. In this lecture, after this, I am going to discuss about the arc blow effect. The molten weld pool is protected from the atmosphere due to the vapors surrounding the electrode, metal, and molten weld pool. Now the results in long arc. What are the results in long arc? Large heat loss into atmosphere, unstable arc, and weld pool is not protected. Weld has low strength, less ductility, poor fusion, and excessive spatter. Large amounts of heat loss into the atmosphere, leading to poor penetration and fusion. Unstable arc due to increased effect of the magnetic arc blow. Weld pool is not protected from the atmosphere. Because of this, the weld gets contaminated due to the absorption of oxygen and nitrogen. Weld has low strength, less ductility, which is due to high porosity, poor fusion, and excessive spatter. These are due to the high porosity. Arc length should be equal to diameter of the electrode. This is the electrode diameter, and this is the arc length. So the arc length should be equal to the diameter of the electrode size. And the bead width, this is a bead, or the bead width should be the 3 times of diameter of the electrode. Now I am going to discuss about the arc blow in the DC arc welding. There is an arc blow in DC welding because of the magnetic flux. Why arc blow occurred in the DC welding? Arc blow is the wandering arc that occurs during the welding of the magnetic materials with the magnetic materials such as steel with DC system, when the cross section of the metal being welded is not symmetrical about the electrode. The effect of arc blow is maximum when the welding corners where the magnetic flux field concentration is maximum. Arc flow is maximum when the magnetic field concentration is maximum at the corners. The effect is proportionally noticeable when the welding is bare electrodes. This effect is occur when the electrodes are the bare electrodes or when using the currents below or above. If we use the currents below or above the electrodes, then these type of effects are occur in the DC weldings. The unbalanced magnetic forces in this situation causes the DC arc column to wander from what should be its normal position. The chance of the magnetic arc flow are more in DC welding than the AC welding. In this diagram, we can see this is a electrode in which is conductor. Due to this conductivity, the magnetic flux field is generated in the electrode. Due to this, when the welding done in this magnetic field, the arc below occur, and this arc below is generally occur in DC arc welding. Effect of arc blow: low heat penetration, excessive weld spatter, pinch effect in the welding is result in the electromagnetic forces, and weld spatter occur due to high welding current and too small electrode arc. Low heat penetration in the weld zone leading to incomplete fusion and to the bead porosity. There is a excessive weld spatter that is throwing out of tiny droplets of weld metals out of the point onto the base metal, resulting in tiny dots on the base metal plates. Pinch effect in welding is a result of the electromagnetic forces, and the weld spatter is due to the high welding current and too small electrode arc. The effect of arc blow can be minimized with the DC welding by shortening the arc of the length, reducing the current used, which will reduce the strength of the induced magnetic field, reducing the weld speed. Reducing the rate of the travel of the electron can reduce the weld speed so that the effect of the arc blow can be minimized. Balance magnetic field by placing one ground lead to each end of the workpiece, putting steel blocks near the ends of the workpiece so that the flux lines flow through them and not through the air. Wrapping the electrode cable a few turns around the workpiece. Thank you so much. If you have any doubt or query, you can comment on this video. I'm going to close this lecture now. In the next lecture, I will discuss about the different type of arc welding, tungsten arc welding and metal inert gas welding. Thank you so much.